So for calculus homework number 30, we have a series of graphs where we are given the derivative of the function, and we're going to be sketching a possible graph of the actual function. So in order to do this, I'm going to create a series of intervals where I'm analyzing what's going on in my derivative. So I'm going to start right here, and the first point of interest that I have is this local minimum. So I know that at this local minimum, I have a point of inflection. I know right here, I have a 0 for my derivative, same for over here. And then I have a local maximum at this point, and that also causes me to have a point of inflection. So as far as the sign of the derivative goes, it is negative for this entire portion, and it is negative and decreasing for this section, and then negative and increasing for this section. For this, it is positive in both, but here it is positive increasing, here it is positive decreasing, and then finally negative and decreasing down here. So what does that mean for my actual function? Well, actually, let me go ahead and label this as f prime of x in red. And then for f of x, let's translate some of this. So this decreasing to increasing means that I go from concave down to concave up, and that's concave up for those. And then all of a sudden, it is now concave down again for these parts here. So when I go to graph this, I am going to first start by saying, all right, when f prime is 0, that is when my function is horizontal. So at those 2 points, I'm going to have 2 tangent lines that are horizontal. So let's just kind of start somewhere near the origin and just go from there. So first off, my function is decreasing, and it is concave down. So what does that mean? That means that I'm going down like this. Then at this point of inflection, it changes to concave up, but it is still decreasing all the way to this 0, where it's horizontal for a moment. Then it is still concave up, but it is now increasing, so it has a positive slope. Oops. Increasing with a positive slope. And then at this point right here, it flips from being concave up to concave down. And it does that to where we get to a 0 again, so it goes horizontal for a moment. And it's still concave down, but now it is decreasing. So this blue line, which I will go over once, is my graph of f of x. And so keep in mind, what I'm really looking for are what happens at each of these segments, where there's a 0, where there's a point of inflection, 0, and those are my points of interest. Question 2, I'm going to go through the same process and find all of my points of interest for f prime of x. So firstly, I have a 0 right here. I have a maximum right here, so this is a point of inflection. I have another 0 right here, this is a little smushed together. And then I have another point of inflection right here. And then I have 2 kind of horizontal asymptotes at either side. So these horizontal asymptotes just means that it goes to some constant slope at the edges. So it goes to some negative and constant value at the end. So negative, constant. Pardon me. It's difficult. I'm going to zoom in a little here. So we have a negative and constant slope on both ends. So what's going on with the value? So the value to the left of the 0 is negative, positive, positive for those intervals, negative, and negative for those intervals. So now I'm going to say, all right, this is negative, and it goes from 0 change to increasing. Then here it is positive and increasing. And then at this point of inflection, it goes to decreasing, decreasing, and then for here on over, we have increasing all the way to 0 change at the end. So what does this translate to for my function? So for f of x, I have a slope of 0 for a while, and then I have a portion where I have a negative slope, but I am concave up. This is still concave up to my point of inflection. This is concave down to my next point of inflection. And then we have concave up for this portion. So to draw this, I'm going to start somewhere up here. I'm going to be decreasing. Let's just start at the axis. So I'm going to be decreasing at some constant rate up until about right here, at which point I'm going to be decreasing, but I'm concave up. So I'm going to flatten until about right here, which is where my line goes horizontal at the 0. And then I'm increasing concave up to the point of inflection, at which point I switch to concave down, and then I go horizontal where this 0 is. And then I'm still concave down, but now I'm decreasing, so I have a negative slope. So I'm going to be going down until about this next point of inflection. And at that point, I have concave up, but I end up going at a constant rate eventually. So I'm going to be concave up until about right here. Let me do this a little more exaggeratedly. About right here. And if I can make this a straight line, pardon me, this is much more difficult than I thought it would be. Then I just have a straight line at the end here. And it should actually be the same slope as over here, so I'm going to try to do that. So I'm going to do concave up, and then concave up, and then straight line. So you have something that looks a little bit like that. Hopefully you have the same shape. So we have points of interest right here. It stops being a constant slope. Here is where it goes horizontal. Here is where it has a point of inflection. Here we have a horizontal line. Here we have another point of inflection where it goes from concave up to concave down. And then about right here, it goes back to having a constant slope. For question number 3, we're going to start again with f prime of x and pulling out all of the good bits. So here I have a local maximum. So that's a point of inflection. Here I have a 0. Here I have another local max, or a local max. This was a local min, I'm sorry. And then finally a 0 right here. And so over here we have all negative values. We have a negative value here, positive value, and then negative value. For this portion we have negative and decreasing. And we have negative and increasing after this point of inflection. Then we have positive and increasing, then positive and decreasing, and finally negative and decreasing. So how does this translate to f of x? Well, if I'm negative and decreasing, this is concave down. This is, now when I go to increasing, this is concave up. And then this last portion is concave down. And then at the zeros, that's where my line is horizontal. So I'm going to start with a slope that is near 0, but I am decreasing, and I'm concave down. So I will look something similar to what's already there. Then I have a graph that switches to concave up. Actually, yeah, this is fine. So concave up, and so I'm going concave up to a horizontal portion right here. Then I am still concave up to this point. And then once I get there, I have a point of inflection. I switch to concave down, but I'm still increasing before I finally get to a 0 or horizontal portion right there. And then I have concave down, so it looks something like this. For question number 4, I'm going to go through this process. So I have f prime of x. So I have several different points of interest. So I have this point right here where f prime of x is 0, and this point right here where f prime of x is 0. Then I have a local maximum right here, so that's a point of inflection. Here I also have a local minimum, so this 0 happens to be a point of inflection as well. We'll see what that means in a second. And then for this entire stretch on the left, we go to a constant value at some point, and it's positive for this entire stretch. So once I'm here, I am still positive. Then this is positive, and I'm sorry, this is positive and then negative. And so the second part is this is positive and decreasing. This is positive and increasing, positive and decreasing, and negative and decreasing. So how does this translate to a function? So for my function, I'm going to have a constant slope at this endpoint here. This right here is going to be concave down. Here we have concave up, and then this whole section is concave down. So I'm going to start somewhere off to the left here, and I have a nearly constant slope, so I start essentially linear going upward to begin with. And I am concave down, and I'm going to a slope of 0 all the way over here. So I'm going to just like sketch a little part where I have 0 slope, which is where I'm horizontal for a second. So that part is just way over here. So I'm going to sketch something that looks like this. So it's concave down, and it's increasing the whole time. Now I am concave up, and I have to go still increasing, and then I have a horizontal part up here. So I'm just going to sketch another horizontal section, and right here I need to have a point of inflection. So I'm going to just pick a point right there. And so that means I start concave up, and then I flip to concave down, and then I have a very negative slope, so I'm still concave down. So I look something like this at the end. So my sections are right here. Here is a point of inflection, and here is a 0 slope. So for number 5, I'm going to go through this process where I have f prime of x, and we have some near constant slope over here. Then we have 1, 0, which is right here. We have a local maximum right here, so this is a point of inflection. And we have a local minimum over here, which is also a point of inflection. And then for this left section, we have a positive slope. So these are all positive. This section is positive as well, as is this, and this is negative. Then this section right here is positive and decreasing. This section is positive and increasing, positive decreasing, or negative decreasing. So to trace this to an f of x, this section right here would be concave down, this section concave up, and this whole section over here would be concave down. So this 1, 0 means that I have a horizontal point right here. So I'm going to start off to the left, and again I'm going to start someplace where I'm positive, and I have a point of inflection about right here somewhere. So my point of inflection, I'm switching from concave down to concave up. So this is concave down and increasing, and this is concave up. So I'm going to have a little section that has not quite horizontal, but essentially like a flip from where I'm going to concave down to concave up. And so my line, my function in between these 2 points is going to be curving upward. It's not quite going horizontal. Then for this next section, I have another point of inflection where I go from concave up to concave down. So again, I'm going to have like a little flat section. And then I have a 0, so my line goes horizontal for a second up here, and then I'm decreasing. So I go this way, concave up, flip to concave down, and then decrease. So my little sections are right here, where I have a point of inflection. Here, I have another point of inflection. Here, where I have a horizontal section, or an instant, and that's it. For question number 6, I have a little bit of a simpler looking f prime function. And so I have a local maximum right in the middle, which means I have a point of inflection. And then I have some kind of asymptotes to the left and right, where my value goes to 0, but it's not quite 0. Then, in between those, I simply have positive values. Now, for the left, I have positive and increasing values, and to the right I have positive and decreasing values. So for my function f of x, this left-hand section will be concave up until this point of inflection, and the right-hand section will be concave down. So what does that mean? Well, that means I have a slope of 0 off to the sides, so here and here. And actually, let me use a slightly thicker line here. So to the left and to the right. So it's essentially 0. It's getting there. Slightly positive. Then I have a point of inflection in the middle where I'm going from concave up, so I'm curving upward, to concave down. So really, I don't know that that's where my line is. So I really should go left to right. So I have concave up, and then I am switching to concave down. So I go again to some kind of horizontal bit. So I could draw something that looks concave up for here, and then flips to concave down over there. And again, this can be shifted anywhere up and down because I don't really know initial values. For question 7, I have a 0 for my derivative at this location. Then I have a negative value right here. And at this point, I kind of go undefined. So I don't quite get to put a number there because I kind of go straight down. I start heading asymptotically down. So at this point, it's undefined slope. And then we kind of just go off this way with some kind of positive slope. So for this section, we have negative but increasing. And for this section, we have positive and increasing. So for our actual function, f of x, we have a situation where we're not defined at all over here. Then we have concave up for the entire section. So what does this end up looking like? Well, I have something that will come down. So I have an undefined slope like this. And I will have a 0 slope at this point. So I'm going to have something that's horizontal. So I can put this really anywhere. So I'll come down to this point where I have 0 slope. And then I will flip to increasing value. Something like this. And so my sections here are really just this one location where I have a 0 value, and then I have nothing to the left of this point. So I should have nothing on the other side of this axis. For question number 8, I have a fairly simple derivative, and I have a 0 value for that derivative right here, and a 0 value for that derivative over here. Then I have a local minimum right here, so this is actually also a point of inflection. And here I have another local minimum, so this is a point of inflection as well. And the values for my derivative are positive to the left, positive in the center, positive here, and negative here. And this is positive and decreasing. This is positive and increasing. This is positive and decreasing, and this is negative and decreasing. So for my actual function, I will have a concave down function up until this 0. This will be concave up, and then the remainder will be concave down with a horizontal section here and here. So firstly, I will start with a horizontal section that I will have something that is concave down to with a positive slope. So let's just say I have a horizontal section here. I start very negative, and I'm increasing concave down up to this point. So now I have a horizontal section, and I flip to concave up. And so I'm going to be increasing concave up until I get to some point of inflection here. My apologies. So we get to a point of inflection right here. And I'm working up to being, so I'm going to move concave down to some horizontal section. So I'm going to go concave down up to that point. And then I am decreasing and I'm still concave down. So I'll just do something that looks like this. So again, my sections are right here. I have a horizontal section. Then I have a point of inflection that corresponds with this local maximum. And then I have a 0 that could have lined up a little better at this point. So for question number 9, I'm going to actually start this one by doing all of my points of interest. So firstly, I have a local maximum that looks to be about right here. So I'm going to go ahead and draw a vertical line right there. I have a 0 that occurs right here, another vertical line. A local minimum that kind of occurs right here on the axis. And that's pretty much it as far as points of interest go. So this in my derivative corresponds to 1, 0, and then 2 points of inflection. So at this point of inflection, I am positive, and then I'm going to still be positive, but this is positive increasing while this is positive decreasing. Here, I have now a negative value for both of these sections, but this is negative decreasing and this is negative increasing. So for my actual function, this section is concave up, this section is concave down with a horizontal point, and this is concave up. So I'm going to start by increasing at some amount in a concave up fashion. So I'll just start down here since I'm increasing. And so I'm increasing concave up until this point. Then I switch to concave down. And I'm going to go up to here until I am horizontal. And then now I have a negative slope, so I'm going to be moving downward for this next section. And then I switch to something that is concave up. And so, oh, I did forget actually that there is a 0 all the way to the right. So there's a 0 over here that I did not see. And we switch back to positive, and so we actually have concave up over here because we are increasing in value, and we have a horizontal point over here as well. So this is concave up from here to a horizontal. To make this a little less drastic. So concave up to a horizontal line at this point, and once we get to this horizontal bit, we start increasing. So these are my points of interest, here, 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 and here. Question number 10, my derivative will have a 0 at this location and this location. It will have a constant value at the extremes, so the left and the right extremes, and it will have a point of inflection right here in the center. So we have a negative value to the left up until the 0, positive values in the middle, and then negative values on the right. So this is negative, and pretty much up until here, for this little section right here, it is negative but increasing. Here it is positive and increasing. Here it is positive decreasing. And then up until about right here, it is decreasing. So for my function, I'm going to actually have concave up. Then I'm going to have still concave up. And then this section over here is concave down. And we have horizontal at these 2 points. And then we have a point of inflection right here in the center. So I'm increasing at some positive rate. I'm decreasing at some positive rate to begin with up until this point. Then I start to, with a concave up curve, go to a horizontal right here. So I'm going to keep decreasing and then curve. Then I am increasing for some amount of time before I flip to concave down, and I'm actually going to be horizontal up here, so I'm going to be concave down. Then, still being concave down, I'm going to work back to being a constant slope over here. So I'm going to go this way, concave down, and then just constant slope over there. So my interesting points are here, 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 and about over here. So for question 11, we actually have a very simple looking derivative graph where we just have a negative and constant value up until this point. And then we have a positive and constant value up until this point. And it's undefined essentially right there. I mean, we have like, it's positive right at this point, but it's kind of weird. So if you see, we actually have like an absolute value in our equation for the derivative. So this is kind of an odd situation where my function has to have a negative and constant slope, and then it has a positive, it's the same positive constant slope right here, and then all of a sudden it has a positive and constant, I'm sorry, this should be negative at this point. Not positive and constant, it should be negative right there. So what does this end up looking like? Well, I have a negative and constant slope, so I can just keep going down like this. And then it's defined right there, and somehow I now have a positive and constant slope. So now I just have something that looks like this. So it looks kind of like an absolute value.